इलास्टिक पोटेंशियल एनर्जी वीटेक। तो हमारे पास स्प्रिंग है, कोई बॉडी है अदर। तो फर्स्ट स्प्रिंग है, उसको हम यहां से पुल करते हैं, तो बाद में वो मोशन करता है। मीन्स हमने जो पुल किया है वो एनर्जी स्टोर इज इन अ फॉर्म ऑफ पोटेंशियल एनर्जी। हम रिलीज करते तो आफ्टर इट टेक इनिशियल पोजीशन, ओके, तो वो पोटेंशियल एनर्जी कन्वर्टेड इन अ काइनेटिक एनर्जी। तो हियर वी स्टडी इलास्टिक पोटेंशियल एनर्जी, restoring force and spring constant first. When a spring is stretched or compressed from its normal position, x equal to 0, this is the normal position, by a small distance x, then the restoring force is produced in the spring. So here we stretch at a small distance, okay, then produce a restoring force. According to Hooke's law, this restoring force is proportional to the displacement x and its direction is always opposite to the displacement. Okay, तो हम जितना ज्यादा स्ट्रेस या पुल करेंगे उतना फोर्स ज्यादा लगेगा। मीन्स एफ प्रोपोर्शनल टू एक्स बट ऑपोजिट टू डिस्प्लेसमेंट, तो वी टेक माइनस एक्स। ओके, तो वी टेक माइनस एक्स, we take minus x. F equal to minus kx, k is the proportionality constant, equation number 1, where k is called spring constant. Okay, if x equal to 1, f equal to k, so k equal to f we take. So spring constant is numerically equal to force required to produce the unit displacement, means compression or extension in the spring. If required force is more, then the spring is said to be more stiff and vice versa. Actually, K is measure of the stiffness or softness of the spring. ये हमें याद रखना है. K is measure of the stiffness or softness of the spring. That means K equal to F by X, its unit is Newton per meter या डाइन पर सेंटीमीटर, न्यूटन पर मीटर या डाइन पर सेंटीमीटर. डायमेंशन फॉर्मूला m1 l1 t minus 2 by l कैंसिल m1 t minus 2. तो K की डायमेंशन फॉर्मूला ये मिलती है. तो इसके अलावा सरफेस टेंशन है, सरफेस टेंशन S इज इक्वल टू फोर्स पर लेंथ. इसका यूनिट भी न्यूटन पर मीटर आता है. इसकी डायमेंशन फॉर्मूला भी ये है. तो स्प्रिंग कांस्टेंट्स इज इक्विवेलेंट टू सरफेस टेंशन. तो ये भी हमें याद रखना है कि इक्विवेलेंट के इक्विवेलेंट कौन सी फिजिकल क्वांटिटी है, सरफेस टेंशन है. तो यहाँ पर दिया गया डायमेंशंस ऑफ फोर्स कांस्टेंट is similar to surface tension. Okay, so experience for elastic potential energy expression. तो पोटेंशियल एनर्जी ये तो हमने फोर्स डिफाइन किया. अब 10 मिनट के बाद फिर से ज्वाइंट हो गया, लेकिन लेते हैं अभी 5 मिनट तक. When a spring is stretched or compress from its normal position x equal to 0, work has to be done by external force against the restoring force. Means F external, F restoring, kx. તમે रिस्टोरिंग फोर्स जितना ही एक्सटर्नल फोर्स देंगे तब वो स्ट्रेस या कंप्रेस होगा. Let spring is further stressed through the distance dx, then work to dw equal to F external into dx, means F external dx to kx dx. Therefore, the total work done to stress the spring through a distance x from its mean position to now take integration 0 to x dw 0 to x kx dx, k common, integration x square by 2 0 to x. So w is equal to 1 upon 2 kx square. This is the work done by external force. This work done is stored as the potential energy of the stretch spring. This is the formula for potential energy. Now take a graph. So U equal to U is equal to 1 by 2 kx squared. Now put k equal to f by x. So k equal to f by x. Then U equal to 1 by 2 fx. Also, here we put f equal to kx. Then x equal to f by k. Put x equal to f by k. So U equal to f square by 2k. So these three formula, U equal to 1 upon 2 kx square, U equal to fx by 2, U equal to f square by 2. This three formula is the potential energy. If the spring is stressed from initial position x1 to final position x2, then the work done is increment in elastic potential, the 1 upon 2 k x2 square minus x1 square. Now, energy graph for a spring we take at any point x, potential energy equal to 1 upon 2 kx square. Now at extreme position, extreme means amplitude. At x equal to plus a or x equal to minus a, this is the x equal to minus a, this is the x equal to plus a. This is the extreme point. After that point, block is returned to its initial point. Okay, so take x equal to a, so U equal to 1 upon 2 k square. So this is the maximum potential energy or total energy of the system. So E equal to 1 upon 2 kx square. We learn about total energy is in chapter number 13. Okay, so now here extreme point. At extreme point, velocity 0, then kinetic energy 0. At any point, the total energy, kinetic energy equal to potential, total energy minus potential energy. So now put total energy 1 upon 2 kx square, kinetic energy 1 upon 2 kx square, for total k square, kinetic kx square. So we write in a form of k equal to 1 upon 2 k is square minus x square. Now draw graph. At a midpoint, x equal to 0. That means potential energy 0. At midpoint x equal to 0, then k equal to 1 upon the k square. It means maximum is equal to total energy to total energy. Okay. At extreme point, kinetic energy 0. The potential energy is maximum 1 upon 2 kx square. So here extreme point, potential energy maximum, and kinetic energy 0. Now a draw graph. Okay. So these two graph draw. This is the potential energy graph, or this is the kinetic energy graph. Intersect to that 2 point. this point. So this point we take a P. So this point is take a Q. To intersect kinetic and potential energy graph means this point kinetic energy is equal to potential energy is equal to half the value of total energy. U equal to 1 upon 2 kx square, 1 upon 2, E equal to 1 upon 2 ka square, 1 upon 2 k cancel both side. So x both side cancel 1 upon 2k. Then take square root both side. So x equal to plus or minus a by root 2. So means this distance is minus a by root 2 and this distance is plus a by root 2. This. तो कोऑर्डिनेट ऑफ द पी का कोऑर्डिनेट हमें मिलेगा पी पॉइंट का, तो ये है एनर्जी, ये है ओरिजेंटल डिस्टेंस, तो माइनस एक्स बाय रूट 2 ई बाय 2 और क्यू का कोऑर्डिनेट मिलेगा प्लस एक्स बाय रूट 2 ई बाय 2। ये हमें याद रखना है। ओके, तो इसका कोऑर्डिनेट हमें मिलता है यहाँ पर काइनेटिक और पोटेंशियल एनर्जी की वैल्यू है टोटल एनर्जी से हाफ, तो हमें ये पोजीशन मिलती है माइनस ए बाय रूट 2, यहाँ पर मिलती है प्लस ए बाय रूट 2। ओके, अब आगे a long spring is stretched by a 2 centimeter. Its potential energy is U. If the spring is stretched by a 10 centimeter, the potential energy stored in it will be 2 centimeter means K constant. So U proportional to x square, U2 by U1 equal to x2 by x1 square. X2 equal to 10, x1 equal to here we take x1 is equal to 2, x2 is equal to 10. So 10 by 2. So 10 by 2 means 5. 5 square equal to 25. So U2 equal to 25 U. Second, next, a spring of spring constant K 5 to 10 is to 3 Newton per meter is stretched initially by 5 centimeter from the unstretched position. Then the work required to stretch it further by the another 5 centimeter. Okay, so first 5, another 5, last कितना हुआ x2 10 centimeter. तो हमने लिया था डेल्टा u इक्वल u2 minus u1 1 by 2 x2 square minus x1 square equal to 1 by 2. K is given 5 into 10 is to 3. x2 10 into 10 is to minus 2 square minus 5 into 10 is to minus 2 square. Calculate. Then we derive 18.75 Newton into meter. तो स्टॉप करते फिर से 10 मिनट के बाद ज्वाइंट हो गए।